Hi, everybody, and welcome back to Chee-Tash. My name is Chris, and today we're going to continue along our journey through the book Clean Code with Chapter 17 titled Smells and Heuristics, of course, by Robert C. Martin. And if you guys remember, last time we went through a couple live coding examples showing just in live time some of the principles that we've been going through throughout this book. We talked about, some different things with naming conventions, keeping things small, single responsibility, the use of interfaces to cut down on repeating code and to provide more code reusability. We talked a little bit about comments, talked about function arguments. We talked about exposing data, when to expose data, when not to expose data, or what to use to expose data. So check out those videos for a live coding example, and definitely let me know what you guys think about those videos, and we can definitely do more of those live coding examples to just keep building off the quote-unquote grocery store project that I had there. But today brings us back to the book, which is we are almost done with. Actually, chapter 17 is the last chapter, and there's additional appendices that we can go through that talk about concurrency, so maybe I'll do some videos regarding those. But this chapter is more of like a reference or a dictionary on just what different smells and heuristics mean. And it's basically just like a one-by-one, and he says it specifically in the book that and this is him talking, Robert C. Martin, I compiled this list by walking through several different programs and refactoring them. This list is meant to be read from top to bottom and also to be used as a reference. So there you have it. And we're going to go through this kind of quick, and this will probably be a two-part video because there's a lot of smells and heuristics. And there you go right there, a chapter meant to be used as a reference. So just starting at the very top, he talks about comments and all the bad ways to use comments. So inappropriate information in comments. You should not have stuff regarding change histories, historical data. Remember, we talked about legal information. Anything like that should not be put in a comment. You should keep it in other areas. You should keep it in like a OneDrive document, in an Excel document, something like that. Don't have that in OneNote. Don't have that in a comment in your source code. Comments should be used, any sort of information like that, keep it to tech notes or keep it to notes about code design, small little details that you can't describe using just the function name or the class name itself. And we're going to talk about that a little bit later, I think. Just don't include inappropriate information in comments. Also, don't keep obsolete comments. If over time you write a comment and at the time you wrote it, it was needed, and a year down the line, the code base changes, and all of a sudden that comment is no longer needed because you did some refactoring, you renamed your classes, you restructured your methods, and all of a sudden things are just clear on their own. If a comment is obsolete, get rid of it or rewrite it. Or how about this? How about just get rid of it if it's irrelevant? Redundant comments. If a comment describes something that describes itself on its own. Yes, this is what I was thinking about earlier. If you have a function, calculate sum, do you really need a comment that says, hey, this is going to output the sum of two numbers? Don't use redundant comments if the functions or the classes or the variables describe themselves on their own. Poorly written comments are just not worth writing. And if you're going to write a comment, the saying in the book was, if you're going to write a comment, it's worth writing it well. Don't write a poor comment. Commented out code is, and he takes it to a very extreme level here, it's an abomination. You should not have commented out code, and I am definitely guilty of this, especially when I'm trying to make my feature branch of work for the project pass in the pipeline. I comment out tests, especially in the early phases, and I uncomment them later on, but in the early phases just to get the feature branch to build so then I can test with it. So probably not a good idea to do. I should probably focus on just getting those tests to pass anyway. But commented out code, just delete it. No need for it, says Robert C. Martin. Next section, he talks about the environment and how one smell is if a build requires more than one step. I don't know if you'd call that a smell or a heuristic, but one red flag, I guess, is if a build requires more than one step. So building should just be something super simple. You hit run, project builds in a single operation. You shouldn't have to do multiple steps to build something. Shouldn't have to run multiple scripts, etc. And I have seen projects like this at work in my career where you do have to run scripts in order for the project to run. So you have to run like a couple different scripts in order to build like a database instance, get the tables running, and then finally you can get your tests to run in that instance. And it should just be all in one fell swoop, I think is what Robert C. Martin is saying. Which goes along with the next bullet point. Tests require more than one step. They should just be quick and easy. And they shouldn't be required to have more than one step or be overly complicated. Make those tests easy. Okay, maybe integration tests can be a little more detailed, but for unit tests, those should be, pretty straightforward, self-explanatory. They should run in one fell swoop. Next, functions. Functions. We talked about how too many arguments in a function is not really that great, and the ideal number of arguments for a function is 0. No argument is best, followed by 1, 2, and 3. More than 3 is very questionable, says Robert C. Martin. This was a surprising thing, I remember, when we talked about the chapter on functions. So try not to have too many arguments in your functions. Try not to have output arguments in your functions. So as he writes in the book, if your function must change the state of something, change the state of the object it is called on. Don't change the state of an object that's being passed into the function. Because, if you build an object, pass it into a function, you can maybe set stuff or operate on that input. So the output is the object itself with extra attributes added onto it. If you guys catch my drift, and he's saying output arguments are bad. If you're going to change the state of an object, change it using the function of that actual object. Don't use an outside function to do that. Flag arguments. Not a great idea either. This is where you pass in like a Boolean, and then you have conditional statements within your function that say, okay, if this is true, do this. Else, if it's false, do this. And Robert writes that this is usually indicative of a function that does more than one thing. If it does more than one thing, you should probably abstract out that functionality and just make your functions do only one thing. And then lastly, is this lastly? Yep, lastly, dead functions. Get rid of functions which you never call. And I think a lot of IDEs, I mainly use IntelliJ. Any of the, what's the company called? It's not IntelliJ. It's they have IntelliJ. They have WebStorm, PyCharm, Golang. What's that company? JetBrains. Any of the JetBrains family of IDEs, at least I know because those are the ones that I use mostly, you'll see function names or variable names grayed out, and you'll be able to hover over it and see it'll hint at you, and it'll notify you that, hey, this is never used. Dead functions should just be get rid of them. It's kind of like comments that are obsolete. If they're obsolete, just remove them. Dead functions, they're not being used, just remove them. Next up, some general red flags, smells, heuristics. I kind of like that red flag name. Multiple languages in one source file. Don't do that, says Robert C. Martin. Keep it simple. And I guess I didn't know this, but in just modern programming, you can have instances where you do have multiple languages being used in one source file. Like you can have JavaScript. And actually, now that I think about it, I'm pretty sure we did this. When in Spring Boot, what's the thing called? Spring Boot Thymeleaf, I think is how you can use HTML in your Spring Boot, and you can actually run JavaScript like in that HTML. It's I haven't used it in a while, but you don't want to have Java mixed in with JavaScript or C++ or any of that stuff. Keep it simple. Your source file should just be one language in your source file. Keep it simple. Next up, obvious behavior is unimplemented. So this is the principle of least surprise that Robert C. Martin talks about. And what he means by this is that if behavior is obvious upon first glance, keep it consistent throughout your code. You don't want any surprises later on because you don't want to have developers mistrusting their intuition on a piece of code. So if something is super obvious, and he has an example in here of, okay, so he has an example of like an enum day date dot string to day, and we would expect that a day of the week would be a fully written out in an enum. Like it would say Monday instead of MON, like abbreviated, right? So if that's the case and that's where everybody's on the same page and everybody expects that, keep it like that throughout your own code and don't make any surprises later on in your code. And that's a very simple example, but you can kind of think of other examples where you just want the least amount of surprises with your code. If something feels intuitive, keep it intuitive, is basically what he's saying. Next up, incorrect behavior at the boundary. So this is basically talking about edge cases and the importance of testing for edge cases. And he basically just says, hey, you need to have tests for the boundary conditions. You need to have tests for those cases of, those exception blocks or those exception scenarios or those cases where the loop is running at its very, very maximum, something like that. I know I'm just kind of spitballing here, but make sure you're writing tests for those boundary conditions and take those into account when testing out your code. Overridden safeties. This is something that I don't think I've really done too much of. Unless we're talking in React, you can kind of like disable some warnings like a max line length. You can actually have React write the suppressing commented out line for you that suppresses the max line length. So maybe something like that is harmless, but otherwise, those safeties are there for a reason, especially if they're compiling warnings, etc. Turning off those compiling warnings or ignoring the failing tests by commenting them out is actually not a good idea overall in a lot of cases, in all cases, I guess, down the road when you need to ensure that a feature is working properly before you spit it out into production. Make sure you figure out any compiler warnings or failing tests right away, says Mr. Martin. Duplication. We learned about this principle called DRY, which is don't repeat yourself, and how he says that duplication is essentially a missed opportunity for abstraction. When you have duplicated pieces of code, why not write one code that then you can reuse in multiple places? Like a function, maybe, like a method that does the repeated code so that you just have to call that method instead of calling the whole, block of code in the method. It cuts down on the size of your files potentially. Code at the wrong level of abstraction. We don't want lower and higher level concepts mixed together. So the example that he uses are like constants. I'm going to read it to you straight from the book. For example, constants, variables, or utility functions that pertain only to detailed implementation should not be present in the base class. The base class should know nothing about them. And then the base class, conversely, there's stuff that the specific implementation of the base class should have that the base class shouldn't exactly know about. So in the grocery store example, we had like the item base class, right? And we had, an apple as something that extends item, right? So the apple is going to have specific things to the apple, like core length, stem length, etc. And the base class might just have price, and I don't know, maybe quantity. I don't know, quantity, or like a packet or package type, if it's an each, or if it's a pack, or if it's a box, etc. So you don't want to mix those two pieces of information together. You don't want to include in specific instance variables in your Apple class, like each count or price, when you can just have it in your base class. So don't mix those instance variables in the different levels of abstraction. Keep the stuff that is meant for the base class in the base class, so that that's reusable in all places. And it cuts down just on you repeating yourself. If you have an instance variable of price being instantiated in your Apple class, in your mayo class, your ketchup class, because you're going to have multiple items, right? So cuts down on code a little bit. Base classes, depending on their derivatives. So that item class that we talked about should know nothing of their derivatives. That item class should know nothing about the Apple class. It should know nothing about that mayo class. But Apple and mayo should know about item class because they're inheriting from it. They're extending it. So it lessens the impact of changes to that, like Apple and the mayo class. Too much information. So doing a lot with a little is a good thing. And you don't just want data hanging out there for everybody to see. We talked about how objects should hide their innards and only expose the data that you want it to expose, so hiding that data. A well-defined interface means low coupling, which means that the variables are not tightly bound to the methods. And let me actually read from you, because I think he put it in a really, really nice way. The fewer variables a function knows about, the better. The fewer instance variables a class has, the better, which means it's less tightly coupled together. And I guess what he means by that is if it is tightly coupled, then one small change in your code in that class or in that interface is going to require you to rework a lot of that class. If you have a lot of functions that take in an instance variable as an argument from your class, all of a sudden you remove that instance variable, you got to go back and change those functions. So keep your methods and instance variables in your classes very, very low. And this will be the last slide, guys. Dead code, much like obsolete comments, much like obsolete functions, starts to smell, starts to rot. It's never executed. Get rid of it. Get rid of that dead code. Vertical separation, we talked about this in regards to classes and how variables and functions should be defined close to where they are used. Local variables should have a small vertical scope. So if you define a local variable, it should be utilized kind of right away, like right underneath it. This is kind of shown whenever you loop through something and you have a local variable. Maybe you're keeping track of count, and then you loop right under your instantiation of that count variable. Again, private functions should be defined just below where they are used. So you have like a utility private function in your class. Well, it should not stray too far from the actual usage of that utility function. Inconsistency. If you do something a certain way, do it all the time. So if you have a certain naming convention for any sort of mathematical operations, let's say, in your code, you always start it with the word calculate, whether it's calculate sum, calculate quotient, calculate product, calculate total. Utilize that same naming convention in all your code. Just be consistent. Don't have any inconsistencies in your code. Next up, clutter. Much like we talked about obsolete functions, comments, dead code, clutter, anything that is not being used, just get rid of it. No need to have it there. Artificial coupling, putting a function in a place that is convenient but inappropriate. So this could be, I'm trying to think of an example here. It's like static functions being declared in specific classes. General enums should not be contained within more specific classes because this forces the whole application to know about these more specific classes. Basically, when you put a variable, constant, or a function in a temporarily convenient, though inappropriate location that is lazy, take the time to figure out, and I'm just reading from the book here, guys, take the time to figure out where functions, constants, and variables ought to be declared, and don't just couple them tightly to a class just because it's convenient at the time. Because again, tightly coupling a class could potentially lead to issues down the line, especially when you introduce more changes and then you have to make more changes because of the changes you made to your class, etc. So be careful with artificially coupling something to a class. And then feature envy. Feature envy is where you envy the scope of the other class. So this is basically where when a method uses accessors and mutators of some other object to manipulate the data within that object, then it envies the scope of that class. So what did I write there in the second bullet point? The method of a class should only use the variables and functions of the class it belongs to, not the other classes. So if you have like that Apple class that we talked about, it should only use the variables and functions within the Apple class. It shouldn't use the variables and functions of the Mayo class for some. I don't know why you would do that, but it shouldn't do that. It shouldn't be envious of other classes. It should have, a class should only utilize the functions that you give it within its own class. It shouldn't need to utilize it from any other class. And with that, folks, that's going to do it for part one. Let's call it part one of chapter 17 of Clean Code. Thank you guys very much for listening. Tune in, the full interview with the YouTube channel Duvid will be out tomorrow. And then I don't know if I will get the second part of chapter 17 out by next week. It might take me 2 weeks because I've got an interview scheduled. I actually got a few interviews that I'm excited for the podcast coming up. So be on the lookout for those. And just thank you guys very much. 888 subscribers at the time of this recording, last time I checked. So thank you guys so much for listening and for the support. My name is Chris. This has been Chee-Tash. Take care, everybody.